Hi, Professor Farooq Asgar. Assalamu alaikum.
Walaikum assalam wa rahmatullahi wa barakatuh.
How are you?
Fine, and yourself?
Thank you so much. Nice to meet you.
Nice to meet you, Professor.
I am Professor Dr. Asaduzzaman from Bangladesh, and my presentation at almost 5:45 p.m. in this session.
It's very nice. It's very nice.
Assalamu alaikum, Farooq Asgar.
Alaikum salam, dear brother.
How are you?
Salam to all. Hello, everyone. I hope you are all fine.
You
So
too.
we are a little bit late, just 1 minute. Hello, dear brother.
No problem. No problem.
Okay, so let me check the program. And all participants, we have 6 presentations in this session. And the first presenter is Osman Muhammad Abdullah. Is he here? Osman Abdullah. I cannot see. Let me call.
Merhaba hocam.
Merhaba. Osman Abdullah'a yazıyorum arkadaşlar. Let me just remind him. Mustafa Manavi is the second presenter.
Yes, sir.
Let us wait 1 minute. If he does not appear, then we can continue with you. Is it okay for you?
Yes, it's no problem.
Okay. And your field is electrical engineering or what?
Electrical engineering. Electrical engineering. Yeah.
Okay. Where are you from?
I'm from Afghanistan,
Afghanistan. Okay. Which city?
Kandahar.
Kandahar. Okay. Very good.
Are you familiar with the cities of Afghanistan?
I know some cities. Of course, the capital.
Yeah.
And I'm not expert about the name of the cities, but I know the ethnicities of Afghanistan. There are Uzbeks,
Yes.
Hazaris, and what else?
Uzbeks, Turkmen, Pashtun, Hazara.
Pashtun, yeah. I had some Pashtun students in Katip Çelebi University. Yeah, Pashtun students. And I know a girl from Ege University also. Afghani girl.
Yes.
Zahari. Her name is Zahari, something like this. Yeah. I think it's better to not wait. Osman Muhammad Abdullah. If you are ready, dear Manavi, you may share your screen and you may start.
Okay, sir. By permission to all my dear friends and professors and guests, my topic is about, shall I introduce myself or it's okay?
You may. It is better to know you.
Yeah, I'm Mujtaba Manavi. Actually, I'm as a lecturer in Afghanistan, Kandahar University and engineering faculty. I had get my bachelor from Afghanistan, and I had got my master degree from Thailand. Asian University of Technology. And now I'm doing my PhD in Turkey. Inshallah, I will be finish it. Today, my topic is about planning distributed generation using optimization techniques in distribution system. As we know that before everything, I would like to give a small information about a short information about the fundamental of electrical industry. As you all of know that an electric power system is defined as a network of electrical components used to generate, transmit, and consume electricity at the last point. Electric power distribution is the final stage, which is deliver the electricity to the consumer. Therefore, every time the problem is at the last point, at the distribution system. So I have studied the distributed generation in the near to the customer point. As we know that the distributed generation is a type of generating plant typically sited near to the customer load or distribution in sub-transmission substation to serve a customer on site and at the same time providing supporting to the national grid. But the problem is what problem of my study that I would like to work on the distribution system. Many times the distribution system suffer many determinants as a result of unforeseen events, making the operation of distribution network unstable and also unreliable. Conventional power system has their own vulnerabilities. For example, high power losses, service reliability, quality of service. For example, the problem of environmental, which is impact on the emission, impacts and their emission. Therefore, the DG is like a golden chance. DG has offer various benefit to the electric power system, but it has also their own challenges. If we don't analyze suitable, therefore we need the explain some optimization algorithm to know which and which we can support the distribution system. The planning of distributed generation installation for delivery rail and reactive power to the system. It has open challenges for many of the research communities, engineers, professors, and for everyone. By optimally sized and optimally located the distributed generation unit, all the problem or we can achieve all the benefits from the distributed generation, for example, minimizing system losses, improving voltage profile, achieving system quality and reliability, loadability, and increasing transmitted power. It requires multiple objective solutions which can be solved by different conventional or meta-heuristic methodologies. Optimization techniques are constantly evolving and have been the focus of many researchers from the last few decades, we can say. The purpose of my presentation, the purpose of my study about this topic is has considered the adoption of that optimization techniques for distributed generation planning and radial distribution system for different power system performance. We point DG types, sizing, distribution models, DG variable, mathematical formulation, participation of different country, and the stated of the distributed generation placement and sizing. I know, I believe that the summary of this literature review helped the researcher and engineer to explore the research gap and to find the future recommendation for the optimal planning of the distributed generation, working with various objectives of the system. This figure has show the objectives of the optimal the algorithms, which focus on that. For example, we can see there from the last 1 decade, I can say that most of the researchers focus on the active power losses. And also they are focused on the voltage stability and to improve the voltage stability and to improve the voltage profile, as well as many of the research focus on cost and investment of the distributed generation, because the conventional power plant is high and expensive, but the distributed generation is the good choice if we can install the optimal size regarding the cost, regarding the power losses, and regarding the improved voltage profile and many other objectives. Here we can see that I have reviewed some of the papers from last, for example, 2010. After the 2010, most of the reviewers, most of the researchers focus on the particle swarm optimization. Also modify optimal particle swarm optimization is the high level. Also non-sorting genetic algorithm is also the most researcher had they used for the distributed generation optimal to get the optimal solution. This is the sorry. And also I have seen that the digitides have been categorized into 2 categories: dispatchable and non-dispatchable. For example, in this papers which I have reviewed, around 88% is the researcher focused on the dispatchable distributed generated types, and 12% is around like non-dispatchable. This is also like some, and they have, for example, the most of them is focused on the distributed generators, which generate the active power to the system, and the second dispatchable, which is like, for example, small power plants. Here is that the researchers work on the, for example, work on the case studies or something. The most of them is work on the standard IEEE distribution system, which is the most of them is focused on the IEEE 30T buses system, and the second step is the 69, and some of them is work on the practical radial distribution system they had worked. And also as a multiple objectives, they had focused on their studies, the different type of loads. For example, a constant load, the most of them is worked on the constant load, which is around 62% of the all of the loads. also residential, commercial, and industrial loads. They are working on that. And also, as a multiple objectives, they had also taken their consideration that the number of DGs. And some studies, they use the single DG in every bus, and they analyze the multiple optimization system, and most of them is like around 93% is around multiple distributed generation in the distribution system. They had used it. And also, not only the account of this, and also they had used like sizing in every part and every bus. They analyzed or they reviewed that from which point of we can have the best results for the for that distribution system to take the optimal distributed generation. Most of them is like around 97% of them is their multiple objective is the size and their locations, and 1% is around their only locations, and 2% is around like only sizes. They had focused on that. And also I have seen that around the world, that in which countries they work on this, and they have interest on the in this study in the optimal distributed generation. And from this figure, we can see that Iran and also Indian is around like the most more than 40 papers I have seen that. And the third part is China is work around. It seemed that most of the Asian country had need to work on this issue, but if we see the European country, they had not worked on that so much. The finding of my finding from this study is, for example, the consider for the DG placement and sizing mainly consider 2 or 3 objectives. Beyond that, I have found that beyond that it will become complex, more challengeable. Therefore, some method need to be adapted for such a problem. The second finding is need to use the hybridization of 2 or more optimization technique, because one is
okay, Professor, I'm ready.
One is for sizing, it's useful, and the another optimization technique is just for see the best location. If we optimize that, so we can find the best result from that. And the third one is the most common and widely used multi-objective optimization, which are the genetic algorithm, and also the particle swarm optimization, which most of the researchers use this 2 algorithms. Exploring the use of hybrid optimization algorithm for intermittent, for example, renewable generation, will be more effective in finding the optimal placing and sizing of renewable generation, and will decrease its computational time, for example. And also some new algorithm is also needed to inspired by various biological or physical phenomena had be focused in the future. Most of the study consider the generation with unity power factor. However, there is a need to include the power factor for observing the non-unity operation and the real world, for example. Intermittent nature of renewable resources may have a certain challenge in coping with the low demand. Therefore, hybridization or multiple renewable distributed generation would offer the challenge of optimization. And the last, I can say that the study, which is based on the systematic literature review, will help researcher and engineer to find robust and reliable optimal analysis method for the most appropriate size and location and type of distributed generation that work with different objectives and algorithm and distribution generation planning, inshallah.
Thank you very much, dear Manavi, for the nice presentation.
Thank you from you.
Thank you. Dear participants, do you have any comments, remarks, any question? No comment. Okay. Since I am a mathematician, I don't have a comment. I don't have a remark.
Thank you so much.
It seems you did something good. So the next presenter is a mathematician from Bangladesh, my brother Asaduzzaman. This is a joint work with him, so he will present the study. Dear brother.
I will stop share.
Thank you. Thank you so much, dear Professor Dr. Farooq Asgar, for nicely present me. And okay. So welcome to all. Welcome to all. I'm very much glad to my dear Professor Dr. Farooq Asgar. Actually, he is encouraged to present this paper here. So, my today's title is Analytical Approximate Solution of Nonlinear Thornburg-Whitham type equations via modified variational iteration method. And this presentation paper is contributed writing by myself and my brother Dr. Farooq Asgar, and our Malaysian professor Dr. Adam Klickman also contribute here. And I'm very much thankful to our contributing author. So my today's presentation outline are abstract, list of abbreviations, introduction, notes on variational iteration method, formulation of modified variational iteration method in the sense of Abbasi-ETL, and solution of nonlinear Thornburg-Whitham equation via modified variational iteration method, and solution of modified nonlinear Thornburg-Whitham equation via modified variational method, and conclusion, and finally gives some difference. Actually, we find some gaps about the well-known variational iteration method for finding the solution of nonlinear evaluation equations, mainly finding the analytical approximate solutions. Actually, we see that there are various various unneeded terms, and more calculation time are needed by using variational iteration method given by V. And from this, regarding this situation, here we observed a paper of Abbasi-ETL, and he shows that there is a new method, alternative use of variation method, and he named this method modified variation method. And using this paper, here we use new two types of equations. First one is Thornburg-Whitham equation, and the second one is the modified form of this Thornburg-Whitham equation. Thornburg-Whitham equation are used to verify the qualitative behavior of the wave break system. So, my abstract from this regard is, here we utilize modified variation iteration method, introducing Abbasi-ETL for obtaining the analytical approximate solution. Dear Professor, are you seeing my presentation?
Yes, we can see your presentation. We can hear you. We follow you. No problem.
You so much. Thank you so much. No problem here. Actually, here we use Maple 2021 software package for finding the analytical distribution. Here, the algorithm used by the modified variation. And finally, I compare this method with the traditional variation iteration method, and compare their graphical representation, and also compare their time-consuming representation by a numerical experiment. This is some elaborated words which are used in this presentation. And first, here we introduce the two main equations by use here. The equation nonlinear Frauenberg-Whitham equation, which is given by equation 1, and Frauenberg-Whitham equation, modified Frauenberg equation, which is given by equation 1.2. This is the only difference between the nonlinear terms u into u of x, and here we use u square into u of x, and these are almost same. And it is some background of these two equations, and there is some background. And we all are known the variation iteration method is very useful method for solving the analytical approximate solutions of different type of nonlinear evaluations, like Barger equation, Barger-Kaplan equation, and other different type of equation, KDV equation also. And for the time limitation here, we are not explain this elaborately. So here the main point is we use modified variation iteration method in place of variation. This is the main target of this paper. So first we give an introduction on the variation iteration method, and in this method we necessarily consider a nonlinear partial differential equation in the form equation 2.1, L u of x and R u of x and N u of x and V of x, and with an initial approximation u of x not is equal to f of x. Here L denote the linear operator only, and R of x denote the linear operator which has partial derivative with respect to n t also, and N u of x denote the nonlinear operator, and V of x denote the inhomogeneous or heterogeneous terms here. And it is well known by everybody that the correction functional or iteration formula given by the variation iteration method as in the equation 2.3, and here lambda is the Lagrange's multiplier and all the variational optimality test by the variational probability. Sorry, here R u of x bar and N u of x bar is the restricted variation, and this is by the variational theory you obtain that the Lagrange's multiplier is lambda is equal to -1. So finally, our equation 2.5 gives the generalized form of the variation iteration method correction functional, and it is the condition of the variation iteration method given by Johnson He. But in a paper or article of Abbasi et al. 2010, which was firstly introduced, Abbasi et al. Observed that and discovered that there are some weak points of the modified variational iteration method, and which is it is not possible to obtain the series solution by variational iteration, like Adam decomposition method. It's another analytical method, and in the series solution obtained by variational iteration method has two parts. The first part is settled part of the approximate solutions, in which can be depend on the and the second part is the unsettled part of the approximate solution, in which cannot be dependent. In the existing variational iteration method needs some modifications to overcome the waste of time in the repeated calculations of unneeded terms, namely unsettled part. And in this situation, to overcome this above mentioned disadvantage of his VIM, that means variation iteration method, 2007 Abbasi et al. Introduced a modification of this variation, which is named as MVIM, that means modified variation iteration method, and which will be discussed in the next slide. Yeah, and we necessarily called the generalized nonlinear partial integration given by 2.1 and 2.3 as like a variational iteration method, and from using the similar process, Abbasi et al. Construct the correctional functional iteration formula in the modified variation as like 3.1. And here we consider that n plus 1 term is obtained by n term in the approximation and this integral. Here we see that the integral is obtained by the linear partial derivatives of un also and un suffix un minus 1. That means n term and previous n minus 1 terms. And here the Abbasidal involved gn of x tau and gn minus 1 of x tau. Here is the question where we can find say gn. In this method, in this direction function, we can obtain minus negative approximation, always 0, and the first approximation is our given term f of x, and un is obtained by this formula given by equation 3.2. It is almost same as the n terms, but there is a difference between adding heterogeneous or non-homogeneous terms. And our desired gn of xt is obtained by the formula nonlinear terms of these equations equals to the gn of xt plus tn plus 1 term, more over tn plus 1, or here O means the terms of tn plus 1 degrees. Okay. And so in this from the equation 3.3 we can obtain gn of xt. And approximately this is an approximation method, but we can see that this after 2 or 3 steps we can get our desired solution, which are converged to the exact solution. So here we get our desired approximate solution by the some iterative step, after some iterative steps. Okay, and this by using this iteration schemes modified given by variation, here we consider our first equation names nonlinear form as beta equation with the initial conditions given by equation 4.1. That means u of x naught is equal to 4 over 3 times e to the power half x. This is the initial condition. And from a paper of Thornberg terms, the exact traveling wave solutions of a considerable non-linear form of beta equation is u of x is equal to 4 by t times e to the power half x minus 2 by 3t, 2 by 3 times t. Okay, I will compare our approximate solution with this exact solution. So our using modified variation iteration method, we consider our un minus 1 terms and u naught and un approximate also, and gn also obtain these equations, and finally we set the correctional functionals un plus 1 of xt, un of xt minus integration according to our considerable equations nonlinear formulation, and we obtained our final iteration formula, which is given by the equation 4.3. And but here is demand that this correctional functional use only for the second or above approximation only, because our first approximation even is obtained by another formula, and it is desired as 2 by 3 and e to the power half x into times t minus t, 2 minus t. Okay. And by using the symbolic subpair package Maple 2021, we obtained the successive approximation of our analytical approximate solution for the nonlinear formal Witten equation by modified variation. And you have seen this way here. And actually here we introduce only the solutions obtained by newly desired Abbasidal modified variational method, but we can compare our numerical comparison and graphical comparison obtained solutions by variation iteration method. So we have already observed that unneeded terms and terms are also eliminated from our obtained solution, and which has very much close to our exact solution. So we can say that our solution is easily converts to our exact solution of these considerable equations. And it is the very good agreement with the exact solution. So this is the comparison table with the table 4.1 gives the absolute error between the our obtained analytic approximate solution and exact solution. And we have seen that the error is very less. So I can tell that our method is our considerable method modified very give high accuracy. And the table 4.2 shows that the time consumption between the our method, our considerable method, modified variation method, and variational regression method. And we see that the time consumed is very less than that of the variational method. Yeah, and you have seen that. Every step we can see. In first step only 0.060 second, but whereas variational regression method takes 0.69 second, and as such, so you can see that time consumption. And it is our graphical representation or graphical comparison. First figure, figure A, shows that the surface of the exact solution, and second figure represent our analytical approximate solution up to 7 theta attribute scales given by B, and almost A and B are same. And sorry, there is a mistake. The number B is also repeated here. Actually, it will be C. The figure C shows that the solution space of the given by the variation group. Almost all are same, but our method takes more or less time than that of the variation method. And so it is already said that our method is to take few times, take short times to converge to the exact solutions. And these are a similar solution of modified nonlinear form of Newton equation have considerable initial conditions. These are different, and this is the big solutions. This is obtained by the modified variation method, and there is only few terms, and it is and for the time limitation, I skip these terms. It is almost same discussion, similar as the nonlinear modified nonlinear form of Newton equation also. And this, so we skip this, and this is a graphical representation of the nonlinear modified nonlinear form of equation, which is obtained by the exact solution and by the analytic approximation B given by our method, and C. Sorry, there is a mistake. So also this last number is B, C, and C, so that the analytical approximate solutions given by variation. So this is almost the same. So, but in this case, our method also takes few less times, and there is eliminated unneeded terms also. So finally conclude that in this study, the modified variation regression method in the sense of Abbasi ETL has been fruitfully applied for obtaining the analytical approximate solution of nonlinear form of Newton equation and modified nonlinear form of Newton equation. And this analytical approximate solution given by modified variation is very much close to the corresponding exact solution, and it is expressible in a closed form also. The obtained solution has been compared with the associated exact solution graphically and numerically, and it is clear that the accurateness of the attained solution are in more acceptable position. The outcomes of this paper prove that the modified variation regression method is suitable, straightforward, powerful, and time-consuming mathematical tools for solving nonlinear form of equation and nonlinear form of modified nonlinear form of equation, also etc. These types of nonlinear evolution also, but for time limitation here we only give two equations, consider two equations only. Finally, in this study we use also simply software package that will be done for calculating another definition of these are considerable equations and their graphical dimension also. So these are some references which are used in this paper, and that's all. Thank you so much, everybody, for your patience here.
Thank you very much, dear brother Asaduzzaman, for the nice and informative presentation. So, actually, I don't have any question. Dear mathematicians, you may have something to ask. Otherwise, we have the next speaker. Any question? Comments? No. Okay, let me thank you again, dear brother Asaduzzaman. Thank you very much.
Okay, thank you very much, everybody.
Next speaker is Talipcan Terman. Jan, you are there? Can you hear us?
Hello, I am here.
Okay. If you are ready, you may share your screen.
Okay.
We can see you now. You are from Ege University or where?
Yes, right. I am graduate Ege University. I'm sorry.
No problem.
Okay, can you see my screen?
Yeah, it is visible. Please first introduce yourself, then your study.
Okay. Hey, hello, everyone. I am Talipcan Terman. I am research assistant at İzmir Institute of Technology from Mathematics Department. And Özgür Ege, who is my advisor, is an associate professor at Ege University Department of Mathematics. Today, we will talk about digital topology and its some properties like adjacency relation, digital homotopy, and finally digital fibration. First of all, what is digital topology? Digital topology is interested in properties of digital image, which are the subset of Zn and relationship to each other. Researchers working on digital topology use some algebraic topological methods like digital homotopy and digital homology to establish stronger relationships between digital images. For instance, digital fiber bundles help us to compute digital homology groups of a digital image. Again, Karaca introduced the notion of digital fibration, which is a generalization of digital fiber bundles. Digital fibration is not an invariant under the fiber homotopy equivalent. Since there is the same problem in algebraic topology, we firstly researched about this question. Then we recognized the need some modifications. The goal of this study is to construct a new structure, which is called digital edge fibrations, and obtain a new invariant. Finally, we show that there exists a relation between digital fibrations and edge fibrations. The first definition is defined in 1994 by Lawrence Boxer. Let Zn is subset of Rn be the set of lattice points for U in Z and P and Q in Zn. Then we say P and Q are Cu adjacent if the following is solved. There exists at most U indices I such that the absolute value of Pi minus Qi is equal to 1. And if for all other indices J, the absolute value is not equal to 1, then we want Bj equals Qj. The definition looks complex. Let me explain this. For example, in Z, as you see, P and left point of P are consecutive numbers. Then we say these points are adjacent. Similarly, right point of P and P are consecutive numbers. Again, we say these points are adjacent to P. Since there are two black points which are adjacent to P, then we say these points are two adjacent to P. Similarly, in Z square, let's look at left image. Let P given a point in the middle. Consider left point of P and P. First coordinates of them are consecutive numbers. On the other hand, second coordinates of them are same value. That is, these points are adjacent to each other. Similarly, upper point of P and P are adjacent to each other. In this time, first coordinates of them are same value. However, second coordinates of them are consecutive numbers. Since there are 4 black points which are adjacent to P, then we say these points are 4 adjacent to P. Similarly, in right image, there are 8 adjacent, then we say these points are 8 adjacent. In Z cube, similarly, 6 adjacent, 16 adjacent, and 26 adjacent, respectively. Okay, the definition, let xi yi in xi kappa I. Here, kappa I is adjacency relation. Given 2 points in x0 times x1, x0, x1, and y0, y1 are adjacent if and only if one of the following is satisfied. Firstly, x0 equals y0, then x1 and y1 are kappa 1 adjacent. Or if x1 and y1 equals, then x0 and y0 are kappa 0 adjacent. And third one, x0 and y0 are kappa 0 adjacent, and x1 and y1 and are kappa 1 adjacent. Often, the adjacence of Cartesian product of digital image is denoted by kappa star. In digital topology, a closed interval is defined like this and is called a digital interval. This set includes integers m plus 1, blah, blah, and finally n. Other definition is about connectivity. Consider lambda's adjacency relation on Zn. Then we say a digital image X, which is the subset of Zn, is lambda connected if and only if for every distinct point m and in X, there exists a set like this, such that m0 equals n, mr equals n, and mi and mi plus 1 are lambda adjacent, where I is this digital interval. The next definition, let x and y be digital image with kappa 0, kappa 1 adjacency respectively. A function f from x to y is called to be kappa 0, kappa 1 continuous if for every kappa 0 connected u, fu is kappa 1 connected. Okay, in classical topology, a path is defined a continuous map from I to x, where I is closed interval from 0 to 1. In digital topology, a digital path is a digital continuous map, 2 kappa continuous, from this digital interval to x. And next definition is about digital homotopy. Let x and y be digital image. 2 kappa 0, kappa 1 continuous map f and g are said to be digitally homotopic in Y if there is a positive integer m and a map hash satisfied the followings. First condition is classical conditions. Hash x0 equals fx and hash xm equals gx for all x in x. Second one, hash x defined by like this, and it is 2 kappa 1 continuous. And similarly, hash t defined by like this, and it is kappa 0, kappa 1 continuous. Also, hash is called a digital kappa 0, kappa 1 homotopy between f and g. Digital fiber bundles is another topic in digital topology. Help us to compute digital homology groups of a digital image. The definition is let E and B be digital image, where B is a kappa 2 connected space. Then the triple EPB is called a digital bundle if the map P from E to B is a continuous surjection. Here, B, E, and P are called base set, total set, and digital projection of bundle, respectively. Also, pre-image of T is called digital fiber bundle of the bundle over T for every T in B. Again, Karaca introduced the notion of fibration, which is a generalization of digital bundles. Here, homotopy lifting property help us to define digital fibration. The definition is let E and B be digital image, let G tilde and hash be digital map and homotopy respectively, such that P O G tilde equals hash O I, where n is a positive integer and I is an inclusion map. And we say P has digital homotopy lifting property with respect to a digital image X. If there exists a continuous map H tilde making triangles below commute, let's look at these triangles. Two triangles are commutative. Okay. The definition is about digital fibration. Let P be a digital map if P has the digital homotopy lifting property with respect to every space X, then it's called a digital fibration. Its basic example, if B is a singleton digital image, then every digital map P is a digital fibration. Let me explain this. Let's previous page. If B is a singleton, that is, B has only one element, then we say P is a constant map. Then P is a constant map. The equation is clearly satisfied. Then we say P has a digital homotopy lifting property with respect to every space. As a result, P is a fibration. Okay, in this work, we introduced digital fiber homotopy because it helps us to define digital H fibrations. Let Q be a digital map. For two digital maps, F and G, we say that F and G are digital fiber homotopic with respect to Q, denoted by like this. If there exists a digital homotopy case such that these equations are satisfied, here K is called digital fiber homotopy between F and G. These propositions are about digital fiber homotopy. First proposition is digital fiber homotopy is an equivalence relations. Second one, let be a digital map. Let P be a digital map if Q and F and G are digital maps such that F and G are digital fiber homotopic with respect to Q, then F and G digital fiber homotopic with respect to P or Q. The third proposition, let Q be a digital map if F1, F2, and G are digital maps such that F1 and F2 are digital fiber homotopic with respect to Q, then F1OG and F2OG are digital fiber homotopic with respect to Q. Homotopy lifting property has two strong equations. That is POG tilde equals G and G tilde OI equals F tilde. But it is hard to define or determine relationship between digital images. But weak homotopy lifting property use fiber homotopy rather than equality. G tilde OI fiber homotopic to F tilde with respect to P. Again, these triangles are commutative. Okay, we introduce digital H fibrations. Definition is a digital map P is called a digital H fibration if it has the weak homotopy lifting property with respect to every space X. Its proposition, the composition of two digital H fibration is a digital H fibration. Other one, the product of two digital H fibrations is a digital H fibrations. And finally, the theorem is the relation between digital fibration and digital H fibrations. The theorem is a digital map is fiber homotopy equivalent to a digital fibration if and only if it is a digital H fibration. Okay, that's it. Here are references. Thank you for your attention. Do you have any question?
Thank you very much, dear Can. So, dear participants, do you have any comments, any question?
Professor Farooq Asgar, actually, yes. I have no any question, but it is a new topic for me. Actually, digital topology. Oh, first of all, thanks to the presenter for his nice presentation.
Thank you.
But I want to know about digital topology. It's a new version of topological space.
Sorry, again.
Actually, I want to know about digital topology. It is the new version of topology, general topology.
Digital
You
topology
can-
is different general topology.
Yeah.
Digital topology was defined in 20 or 30 years.
So what is the definition of
Oh,
digital topology? Maybe it's better to start from.
yeah.
Oh,
Actually, general topology is different on the topology, and these have three properties, and
Okay.
You can explain the fuzzy topology. We may all learn more,
Okay.
but digital topology is very new topic to me.
um,
So if you explained it,
in general topology, interesting sets. Similarly, in digital topology, interested in sets which are the subset of Zn. These are, this image is subset of Zn. The digital topology research, this image is behavior. This image
Yeah.
is this image behavior.
of course, almost is have also some properties with general topology. Actually, fuzzy topology contains different type of properties, and general topology contains different type of properties, and also digital topology contains some different properties also. But I'm not clear. So thank you very much for your new topic, and best of luck for your next research. Thank you very
Okay.
much.
Thank you.
Dear brother Sessıon for the comments. Thank you very much.
Thank you.
So the next speaker is Mustafa Tevfik with some colleagues. Mustafa, you are here from the beginning of the session, but we cannot hear your voice now. Please switch on your microphone first.
Merhaba hocam.
Merhaba. Türkçe
Hoş
biraz-
geldiniz.
Hoş bulduk, sağ olun.
Evet hocam.
Tamam. Ekran paylaşımı yapabilirsiniz. Son.
Tamam hocam. Tamam hocam. Değerli arkadaşlar, hocam hoş geldiniz sunumuma. Bugün size
İngilizce sunum yapabilir misin Mustafa?
hocam İngilizcem çok iyi değil.
Olsun,
Türkçe
olduğu kadar, çünkü diğer hocalarımız da var. Onlar hiç bilmiyor.
yani
En
hocam
azından
hiç
İngilizce kötü de konuşsan
hazırlanmadım.
problem olmaz. İngilizce konuşsan daha iyi olur ya. Memleketin nere?
Ben Iraklıyım hocam.
Irak. Arapça biliyor musun?
Arapça biliyorum, evet.
Arapça yap diyeceğim. Dear brother Asaduzaman, do you know Arabic?
No, I am not.
You don't know.
Arabic. I only.
The brother Mustafa cannot speak English, so we
Dear-
have a language
Dear
problem.
Professor Faruk, maybe you can make a summary for Professor Asaduzaman.
Okay.
Okay, thank you very much.
Okay, let's see.
No. I'll realize my brother Farooq Usgar.
Thank you. Okay, we are sorry, brother. Okay, so we have no choice, it seems. But Mustafa, if you wish, you can shortly explain. But Asaduzaman, you cannot understand Arabic, right? Do you understand Arabic?
I am. Am I?
Yeah, yes, you.
No, I am not understand Arabic.
You cannot. I also
I am-
cannot understand. No problem.
No problem. But I will realize by you.
Okay. Tamam. Devam edelim.
Tamam hocam.
No problem.
Size bugün inşallah SPSS programı ile parametrik ve non-parametrik testleri kullanarak SPSS'te uygulamayı yapmayı göreceğiz. İçindekilerine bakarsak parametrik ve non-parametrik testler nedir, onları bakacağız. Parametrik testlerin varsayımları, ondan sonra kullanacağımız testler ve SPSS programında uygulamaları.
Hı hı. Kendinizi tanıtmadınız da nerede çalışıyorsunuz, ne yapıyorsunuz?
Ben Mustafa Tevfik, Ege Üniversitesi'nde doktor öğrencisiyim. Ziraat Fakültesi'nde biyometrik genetik anabilim dalında Çiğdem Takma, Profesör Doktor Çiğdem Takma danışmanımdır.
Genetikte.
Evet,
Genetik ha.
biyometri genetikte.
Tamam. Dear Manavi, do you understand the Turkish?
Yes, yes, I understand the text.
Okay, so you can translate.
No, the translation
problem.
is very hard.
Okay. So you are lucky.
Yes, I know.
İstatistikte iki grup vardır. Bunlar biri parametrik testler, diğeri ise non-parametrik testler. Parametrik testlerde parametrik testler uygulanmak için gereken varsayımlar vardır. Bunlardan ilki verilerin aralıklı ya da oranlı ölçekle toplanmış olması, verilerin normal dağılım göstermesi, grupların varyansları eşit olmalıdır. Parametrik testlerin daha fazla tercih edildiği görülür. Daha fazla tercih edilmesinin sebebi ise daha fazla istatistik güce sahip olduğudur. Parametrik testler normal dağılım koşulu taşıdıklarından popülasyonu temsil etme gücü daha fazladır. Non-parametrik testler ise bu testlerde verilerin dağılımına ilişkin bir ön şart yoktur. Bir de örnek sayısı 30'dan fazla olduğu zaman ve normallik sağlanmıyorsa, normal dağılım sağlanmıyorsa bu verilere transformasyonlar uygulanır. Bu transformasyonlar sonucu yine normal dağılım sağlanmadığı zaman daha doğru sonuç alabilmemiz için non-parametrik test uygulamamız gerekiyor. Bu testlerden daha çok kullanılan testlerden diyelim Wilcoxon testi, Kruskal-Wallis testi ve Mann-Whitney testi. Bu testlerden grup sayısına göre parametrik ve non-parametrik olarak karşılıklı göstereceğim size. Bağımlı iki grup olduğu zaman Pirate t-test kullanılır. Wilcoxon bunun non-parametrik test karşılığı oluyor. İki bağımsız grup olduğu zaman Independent Sample Student t-test kullanılır parametrikte. Non-parametrikte ise Mann-Whitney testi kullanılır. Bağımsız grup sayısı 3 veya daha fazla olduğu zaman varyans analizi testi kullanılır, ANOVA testi kullanılır. Onun karşılığı ise Kruskal-Wallis testidir. Örnek verecek olursak Wilcoxon testi üzerine bir X hormonu denemesi için rastgele 10 tavuk seçilmiş ve bu tavukların hormon verimlerinden önce ve verildikten sonra kanlarındaki leptin seviyeleri ölçülmüştür. Bu tavukların leptin değerleri üzerine ilgili X hormonun etkisi olmuş mu ya da olmamış mıdır? SPSS programını açtıktan sonra verileri girdikten sonra analyze diyeceğiz. Oradan non-parametric test, legislative logs. Oradan to related sample testi seçeceğiz. Burada bizim değişkenlerimizi birini variable 1, diğerini variable 2'ye aktardıktan sonra Wilcoxon'ı seçeceğiz. Daha sonra option'dan Wilcoxon option'u seçtikten sonra descriptive'i seçeceğiz. Continue dedikten sonra sonuçlarımız karşımıza çıkıyor. Sonuçlarımızda gördüğümüz gibi yukarıda grupların ortalamalarını verdi, standart sapmalarını verdi, minimum ve maksimum değerlerini verdi. Buna göre bu non-parametrik testlerde bir sıralamaya dayandığı için, yani bir sıralama yapıyor ortalamalar için, min rank dediğimiz. Ve bu sıralamalara göre iki grup arasındaki farkı var ya da yok yapıyor. Burada gördüğümüz gibi P değerimiz 0.05'ten büyük olduğu için iki grup arasında fark yani olmadığı ortaya çıkıyor. Mesela H hipotezini red edemedik. Yani tavukların leptin hormonları arasında istatistiksel açıdan anlamlı bir fark olmadığı görülmektedir. İkinci testimiz ise Kruskal-Wallis testi. Burada da 18 tavuk rastgele olarak 3 gruba ayrılmış ve bu gruptaki hayvanlara farklı korku etkenleri uygulanarak tonik immobility süreleri dakika olarak ölçülmüştür. Buna göre korku etkilerine göre tonik immobility süreleri arasında fark var mıdır, yok mudur? Aynı şekilde SPSS test programını açtıktan sonra verilerimizi girdikten sonra buradan non-parametric legacy logs K-independent sample seçeriz. Oradan tests of several independent sample'ı seçtikten sonra gruplarımızı belirleyeceğiz. Define range dediğimizden sonra bizim 3 grubumuz olduğu için minimum 1, maksimum 3 grup diyeceğiz. Bu 3 grubu birbiriyle karşılaştırsın. Kruskal-Wallis seçtikten sonra OK dedikten sonra sonuçlarımız geliyor. Burada da aynen ortalama ve standart sapması, minimum maksimum değerlerimiz, bir de min rankımız. Burada sonuç 0.05'ten küçük olduğu için H0 hipotezini reddedeceğiz. Reddettikten sonra yani bizim gruplar arasında fark vardır. Peki bu gruplar arasındaki farkını nasıl görebiliriz? Aynı Analyze'dan non-parametric testi seçtikten sonra buradan independent sample'ı seçeriz. Buradan ise pencere açıldıktan sonra field'e gelip etkenimizi grupa koyacağız. Test verimizi de test field'e koyacağız. Run dedikten sonra karşımıza böyle bir pencere çıkıyor. Bu pencereyi 2 kere tıkladıktan sonra böyle bir pencere çıkıyor bize. Burada sağ tarafta gördüğünüz gibi Independent Sample Test View dedikten sonra Pairwise Confirmation seçeceğiz. Burada bize hangi grubun hangi gruptan farklı olduğunu gösteriyor. Üçüncü testimizde ise Mann-Whitney testi. Burada da örneğimizde bir yem katkı maddesinin sindirimindeki etkisinin araştırması amacıyla 8 koç ve 8 koyuna bu madde verilerek rumen sıvılarında pH incelenmiştir. A maddesinin koyun ve koçlardaki etkisi anlamlı bir farka sahip midir ya da değil midir? Burada da dediğimiz gibi aynen grupları gireceğiz. 2 tane grupumuz var. SPSS programında. Daha sonra bunları tanımlayacağız grupta, SPSS'te. Daha sonra non-parametric legacy dialogues two independent sample'ı seçeceğiz. Burada cinsiyetleri, grupları ayıracağız. Mann-Whitney testini seçtikten sonra OK'ye tıklayarak burada sonuçlarımız gelecek. Sonuçlar geldikten sonra burada da gruplar, 2 grup arasında fark olmadığını görüyoruz. Çünkü çıkan sonucumuz P değerimiz 0.05'ten büyük olduğu için. Dinlediğiniz için teşekkür ederim.
Teşekkürler Mustafa, sağ olasın.
Sağ olun
Biz
hocam.
teşekkür ederiz.
Uygulama tabanlı bir şey oldu, sunum oldu.
Evet.
Dear participants, this is all for this session. I kindly request you to switch on your camera to have a group photo. Then I will close the session. Evet. Kim alıyor şeyi? Ben mi alayım? Muhammed orada mısın? Muhammed, are you there?
Yeah, hocam, I'm here.
Okay,
Please,
could you,
but
could you-
when can you
Mustafa,
just
sunumu
close
kapatabilir
the
misin?
screenshot?
Hocam bir dakika.
Stop sharing.
Tamam.
Yeah,
Then we will
okay.
have some nice photos.
I will take it now. Okay, 3, 2, 1.
Cheese.
1 minute. Okay. Okay. I think.
Done.
Okay.
Thank you very much.
Yeah,
for your
everything is
time.
fine.
Thank you very much, everyone, for your valuable contributions. This is all for the session. So see you next year. Hope it will be fine. It will be better.
Thank you very
Have a
much.
nice
Thank you
day.
very much,
Bye.
Professor.
Have a nice
Have a
day.
nice day.